Welcome to the lair of the Batty Boffin.
Hi there, Batty fans. It's time for a little more chemistry with the Batty Boffin. Today we're looking at the periodic table. Now, in other videos we've looked at the general structure of it and the history of it. Here we're looking at one of the groups. Here we are as a quick reminder of what groups are in the periodic table. So we're looking at group 1, which is on the left-hand side there. Now, group 1's got a whole bunch of elements in that I'm sure you've heard of. We've got things like hydrogen in there at the top, lithium, sodium, potassium, and then some other ones at the bottom that we don't tend to deal with much because, frankly, some of them are radioactive. Now, we're going to be talking about what happens in these groups, how things are similar, how things change as you go down the group, and some of the common reactions. Now, all of the things that are similar about this group are all dependent on their electron structure. And I've got three here: hydrogen, lithium and sodium, the first three elements. Now, hydrogen's actually a slight bit of an oddball because it's only got one electron, and so it could belong in group 1. It could actually also belong in group 7. So to be honest, we're not going to use hydrogen very much for most of these. But what I've drawn here are the electron shells. Now, there's other videos that tell you about molecular structure, but if you remember, on an atom is neutrally charged. It has no charge, which means that however many protons with a positive charge it has the same number of electrons with a negative charge. And we know how many protons something has because that's the atomic number. Hydrogen is element number 1. It has one proton, so therefore one electron. And you can see it there drawn at the top. Lithium is at element number 3. Hydrogen, helium, lithium. So it's got 3 protons and therefore it has 3 electrons. And they come in these orbital shells, kind of like onions going out here. And the inner orbital holds 2 electrons, you can see them drawn there, and the next one out has got just 1 in, though that makes 3 electrons altogether. Every row in the periodic table is a new shell. So the top row with just hydrogen and helium, that is the inner orbital shell there. Lithium is on the second row down. Here's a picture of it in the periodic table. Over in group 1, which means it has 1 electron in the outer shell, and in period 2, which means it has 2 shells. So there we go, 2 shells. The inner shell just holds 2 and the third electron is in the second one out. Sodium, that's in the third row down, which means it has 3 shells. There they are, 1, 2, 3. And it's element number 11, which means it has 11 protons and 11 neutrons. So here they go, 2 on the inner shell, 1, oh, I've only drawn in one there, let me draw the other one in. 2 on the innermost shell, 8 in the next one, and that shell only holds 8, so it's full there, and then 1 in the next one. So we write out their electron structures like this. Hydrogen is just 1. Lithium is 2, 1. Sodium is 2, 8, 1. So the challenge for you is to have a go with the next element down in this group, which is potassium. So grab your periodic table. If you don't have one, pop along to www.battyboffin.co.uk and there you can find either a black and white one you can colour in yourself if you like, or there's a full colour one if you want to print it out. Look very nice. All the groups are coloured different shades, and that's the way to do it because it's the groups that are important. So having a look at your periodic table, find out what atom number, what element number potassium is. That tells you how many protons it's got, and that tells you how many electrons it's got. And we put them in the orbitals. It's the 4th row down, so it's going to have 4 concentric rings. See if you can draw the diagram for potassium, please. You should have something that looks like this. We have potassium in the middle, symbol K. I don't know why, it's probably just German, maybe. Na is sodium because it's German, I think. Natrium, short for. Potassium, there we go. We have 4 rings because it's in the 4th row of the periodic table, so that means it has 4 shells. And the inner shell has 2. The next shell has 8 electrons. The third shell out also has 8 electrons, and in the outer one, just 1. So that's 2, 8, 8, 1. Potassium being the 19th element, does 19 protons and 19 electrons. Now, as you go down the table, the next one's down, the arrangement of electrons gets a little bit more complicated because the next shell actually holds 18 and they kind of fill sometimes in a slightly weird order, but they always have one in the outer shell. Group 1 always got one in the outer shell. Group 2 always got 2 in the outer shell. Over this side, group 7 always got 7 in the outer shell. That's a guarantee. So there we go. Those are the electron arrangements, and this tells us something about how these things react. Now, all of the elements want to have a full outer shell of electrons. That's how they're happiest, which is why the group 8 elements with the full outer shells don't do anything. These are very nearly a full outer shell. They've just got this one extra. So guess what? They're very happy to get rid of them. All of these elements here are very keen to lose one electron from that outer shell, and then it's got 3 shells nicely full, happy. So that means that potassium here is very keen to lose its outer electron, and when it does, it's still got 19 protons, but it's only got 18 electrons now, which means it's positively charged. So that is K+. The potassium ion, that's ION, not iron, it's the metal, it's still potassium, ION, a charged particle. And the same happens to all of them. Sodium forms Na+. It's keen to get rid of that one and forms Na+, an ion. Lithium, the same. All of these are happy to lose one electron and form a positive ion. So all the group 1s all form positive ions, and since they form ions so readily, they join by ionic bonding. Again, other Batty-Boffin videos about covalent and ionic bonding, but group 1 very keen to form ions, very keen to form ionic bonds. Now, this also tells us something a little bit about the reactivity. You've got a positively charged nucleus, and you've got all these electrons around the outside, and obviously they're kind of held in because positives and negatives attract each other. But these electrons out here are quite a long way from that positively charged centre. These ones here are fairly close. So these electrons are kind of a bit more tightly bound to the centre than these ones are, because these are further away, so there's kind of less attraction there. Which means that this one can lose its electron much more easily than lithium. Okay, so lithium does want to lose its electron, but it's a bit harder to lose. Potassium, it's much easier to lose that electron, which means that potassium is more reactive. So as you start at the top of group 1 and go down, they get more reactive because the bigger they are, the further out is this outer electron shell, and the more easily that outer electron is lost. So starting from the top and going down, they get more reactive, and this is one of these trends that you find in the group. So group 1, they get more reactive as they go down. Other trends, well, obviously each time you go down you're adding an extra electron shell, so the atoms get bigger. So going down the table, they get bigger, they get more reactive, they get denser because they've got more protons, so that's more weight in there. They also get softer. These are quite soft metals. They're all metals, okay? That kind of, they look kind of silvery, look a bit like silver, but they're quite soft. They're about the tendency about like candles. You could kind of cut them with a knife, like you could wax candles. So they're quite soft, and they get softer as they go down. Their boiling points, melting points get lower. So they get more like butter or margarine as they go down, I suppose. Also, interesting one here, they're highly reactive with water. If you put them in water, I'm sure you've seen the experiments where you drop them in water and they fizz around. For this reason, because they are so reactive with water, and they get more reactive as you go down, they're stored under oil, okay, because there's water in the air, okay, you wouldn't want them reacting that. There's also water in your skin, so you never touch these metals. You always pick them up with tweezers or tongs or something. So highly reactive, react with water, stored under oil. Now, is there anything else I need to say? I think that's about it for the moment. So what I'm going to do is going to rub down this board, and we're going to talk about some of the common reactions. And they're quite nice, these, because once you know what happens with lithium, you also know what happens with sodium, and you know what happens with potassium all the way down. Hydrogen is slightly different, as I say, because although it's one electron too much for a neat set of bonds, it's also one electron too little. So sometimes hydrogen is considered to be in group 1, sometimes it's considered to be in group 7. So we're actually going to leave hydrogen out of this. It's slightly different. We're going to look at lithium, sodium and potassium. Okay, that's all from this video. I'll see you another time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!